that has a similar inside diameter to the outer diameter of spent fuel bundles. Radioactive particles will not therefore come into contact with the bitumen that would likely all be produced over the next century. After that, the waste can be retained in a residual tomb of bitumen or be extracted for reuse. Boiling water reactors spent fuel, the majority of the world's inventory, can be recycled without expensive reprocessing in Canada's CANDU reactor using the Dupic fuel cycle. In the course of depleting its bitumen using the global inventory of high-level radioactive waste, Alberta would provide a valuable service to the world by securing the plutonium contained within the waste, even as it matured a replacement source of energy to the one it is depleting. The sedimentary rock in which bitumen is found is also ideal for radionuclide containment, as demonstrated by the fact oil and gas, often under significant pressure, are found there. Fallout is the residual radiation hazard from a nuclear explosion or an accident, such as Chernobyl or Fukushima. It falls out from the atmosphere into which it is spread during the explosion or accident as dust. Unfissioned nuclear material and weapon residues are vaporized by the heat of a nuclear fireball and condense into a fine suspension of very small particles, which are distributed on the winds around the world, and when inhaled, these particles do their damage. With the nuclear-assisted hydrocarbon production method, no such dispersal of radioactive material would occur. Bitumen is a mixture of organic liquids that are highly viscous, black, and sticky. Naturally occurring bitumen is so thick that it must be heated or diluted before it will flow. Geologists speculate that the bitumen found in Alberta's oil sands is a result of bacteria feeding on the lighter hydrocarbon chains that were formed millions of years ago from the remains of tiny creatures buried in the seabed of an ancient ocean that covered the province. The light oil eventually migrated, saturating large areas of sand near the surface, where the bacteria consumed all but the molasses-like bitumen. The problem is, valuable hydrocarbons are short-chain molecules. Methane has a single carbon atom. Wet gas has between 2 and 4 carbon atoms, and gasoline contains between 5 and 9, whereas bitumen is a very complex mixture of chemicals with chains in excess of 2,000 molecules. To increase its value, Alberta's bitumen has to be split, and hydrogen ions have to be inserted where the chains are broken. Ionizing radiation can help this process by splitting some of the bitumen chains underground, and hydrolysis of in situ water provide the hydrogen ions necessary to complete the upgrading process. The resultant hydrocarbons do not become radioactive, just as radiation to prolong the life of fruits and vegetables does not make the food radioactive. Instead of consuming valuable and CO2 generating resources to produce Alberta's reserves, the waste heat of spent nuclear fuel can and should be utilized. It has been said that burning a clean fuel like natural gas to produce a dirty fuel like bitumen is alchemy in reverse. Using nuclear waste in this fashion is technically indistinguishable from any other geothermal energy source, all of which derive energy from the radioactive sources at the Earth's core. Professor Chandra Shekharam, board member of the International Geothermal Association, in a recent Outlook India article, Transforming Nuclear Waste Heat into Power Possible, states high-level nuclear waste in a geologic repository should be considered an anthropogenic enhanced geothermal system with a small volume of waste capable of generating high amounts of electrical power. Most electrical power is dependent on boiling water to power a generator, but a low boiling point fluid can accomplish the same thing.